What's going on, guys? Today we're going to be speaking about something called binomial expansion. The guys who are doing the Cambridge syllabuses or the British International curriculum will be quite familiar with this concept because it's something that's tested quite often in those syllabuses. But as a CAPS or IB students, guys, that this can be only useful to learn, guys. And when we're speaking about binomial expansion, guys, is that we basically have two terms inside a bracket to the power of something. So you see here we have x plus 1 to the power of n, okay? N can be any number, guys. It can be 1, it can be 2, it can be 3, it can be 100, it can be 1,000. They probably won't give you 100 or 1,000 because that'll require a lot of calculations, but just get the idea that that n can be anything when we're looking at binomial expansion. And this x plus 1 inside the bracket, guys, it's not only limited to x plus 1. We use x plus 1 to explain it because it's the one that you can actually see what's happening the most clearly. But that can be anything, guys. That can be 2x minus 5 or half x plus 17, for example, guys. They can be any numbers in there, guys. So just get used to the fact that it's not going to just be an x plus 1 or in a simple form like this, guys. It can be in any number. Okay, so what I've done is that I've multiplied those out for you at different values for n. I've multiplied x plus 1 out. So if we get x plus 1 to the power of 0, the answer is 1 because anything to the power of 0, guys, is 1. Okay, x plus 1 to the power of 1 stays the same as x plus 1. X plus 1 to the power of 2 becomes 1x squared plus 2x plus 1. X plus 1 to the power of 3 becomes 1x3 plus 3x2 plus 3x plus 1. And then x plus 1 to the power of 4 is 1x4 plus 4x3 plus 6x2 plus 4x plus 1. Okay, guys, and now looking at this, guys, we can start to notice something, guys. Is that the first thing that we notice is that, let's go look at x plus 1 to the power of 4 here, is that when we multiply it out, guys, they are appearing in what's it called? Decreasing powers of x, because it started 1 to the x to the power of 4, then it becomes 4 to the x to the power of 3, x to the power of 2, x, and then x to the power of 0 at the end. That's why we have a 1, guys. So you see in this form, guys, x is always decreasing in power, guys. And you see also is that the way that I've what's it called? Shown you visually the multiplication of this, guys. This actually looks like a very similar shape that we use in math, guys. It's a very similar, a very important thing used called Pascal's triangle, guys. And how Pascal's triangle works is that basically it's a triangle with ones all along the outside and in between two numbers and below it. So you see this 2, it's below 1 and 1. It is the sum of the two numbers directly above it. So we look at, let's look at it. So we have 1, okay, 1's by itself. Okay, 1, it has nothing over there, so it stays 1. This one has nothing over there, so it stays 1. Then this one has nothing over there, so it stays 1. Then this here, 1 plus 1 equals 2. Okay, 1 plus 0 equals 1. Then let's look at these ones. Okay, we're going to look at just the middle one. 1 plus 2 equals 3. 2 plus 1 equals 3. 1 plus 3 equals 4. 3 plus 3 equals 6. 3 plus 1 equals 4. So you see, guys, you could easily draw this triangle whenever you want it, guys. It's very simple. You just know that you are multiplying the, you're adding the two numbers above it to get the number below. Okay? But you see that that's actually in the exact same form as the expansion we did up here. You see 1's at the top over there, 1's at the top, then we get 1 and 1, then we get 1 and 1, then we get 1, 2, 1, and then we get 1, 2, 1. And that's because when you're looking at x plus 1, you are always going to have this format. And you'll see that now when I go through it, in binomial expansions, we actually always use this format. So let's look at an example, okay? So this is a slightly more complicated example, still by far not the most complicated one that you guys will see, but it's very important to look at. I think it gives you a good base into how these problems make sense. But let's see, let's look at x plus 2 to the power of 4, okay? What happens is that now we see that's to the power of 4. So if that was any number in there, what we would do is our first step is that we see to the power of 4. So we go to our Pascal triangle. First, I'm going to show you. You see at the top, that 1 at the top is only when x plus 1 is to the power of 0. So the 1 at the top. So when we're doing this, we don't count the 1 at the top because that's where n is equal to 0. So then we go 1 and 1, that's row 1, then 2, then 3, and then 4. And then because it's to the power of 4, we take this row down here, the 1, 4, 6, 4, and 1. Okay, So we take that row and then we say that those are our binomial coefficients. You see I put it down here, 1, 4, 6, 4, 1. Then from this point on, guys, it's very similar. You remember what I said about the decreasing powers of x? Something important to realize is that although your powers of x are decreasing as you go further down the line, your powers of 2, the other term in the bracket, are increasing as you go further down the line. So let me show you what I look at. So first things first, we take our binomial coefficient, we say it's 1, and we times it by x to the power of 4. Okay, because you just take the coefficient and you put it to the 4. We say you could add times 2 to the power of 0 there, because at this point we are not multiplying by 2 to the power of anything, we're multiplying by 1. So you can say times 2 to the power of 0, but I just left it out for simplicity. So you get 1 times x to the power of 4. Then, okay, that's the first term sorted. Then you go to the next term. So you go plus. Then the next one in your binomial coefficients is 4, so you put 4 at the back. You times it by x. Now, because we've already done x4, we now say x to the power of 3 and times 2, because if that was times 2 to the 0 there, now we need to times by 2 to the 1 here. So then it becomes 4 times x to the 3 times 2. That's our second term handle. So now we go plus 6, because our third term has the binomial coefficient of 6, times x to the power of 2, because again we go 1 back from our previous one, which is x to the power of 3, and we add 1 to the exponent of our previous term, so it becomes 2 to the power of 2. So then the third term becomes 6 times x squared times 2 squared. Now we're not quite done yet. Now we need to go look at the fourth term, guys. So now we go. You take your binomial coefficient, which is 4 again, okay? Remember, we got that from our Pascal's triangle. Then you times that by x to the power of 1, because the last term was x to the power of 2, and you subtract 1 from the exponent. And then you'd multiply it by 2 to the power of 3, because we have to add 1 to the exponent for the 2 now. So then it becomes, the third term becomes 4 times x times 2 to the power of 3. Now the last term, okay, this is the last term. We go to our binomial coefficient. We find it has a binomial coefficient of 1. And we multiply it by x. What would the x be to the power of? X is to the power of 0, because our last term was to the power of 1, guys. So we say, so what's x to the power of 0? It's 1, so we leave it out. So it's 1 times 1 times 2 to the power of, the last one was 2 to the power of 3. Remember, we add 1 to the exponent of our second term. So it becomes 1 times 2 to the 4. Then you just multiply all these ones together, but remember, keep the plus signs, guys. We can't add these terms because they have different powers of x. So it becomes x to the power of 4 plus 4 times 2, 8 to the x third, plus 6 times 2 to the 2 is 24, plus 24x squared, plus 4 times 2 to the 3, 2 to the 3 is 8, 4 times 8 is 32, so plus 32x, and then 1 times 2 to the 4 is 16, plus 16, guys. I hope this makes enough sense in handling the binomial expansion. I will see you guys tomorrow. Thank you.